Let's say that in a higher level program like Python, we have a variable equal to b to 5 and b variable is equal to 2. Now we create a while loop in which we say if the content of a variable is bigger than the content in the b variable, then you would want to print a string like hello world. But right now, because the content of a is bigger than the content of b, we would have an infinite loop which prints the hello world on the screen. Now if we hit enter, you see it has been executed and an infinite while loop has been created, so I have to press Ctrl C to stop it. But the important thing in here is that how is it that such a program knows that a variable is bigger than b, or how does it calculate the content of one variable being bigger than the other? We want to see how the Python or higher level instructions are translated to the machine level instructions in here. Well, the thing is that they just look at two different flags. What it means is that if the zero flag, the flags for this purpose are zero flag and carry flag. If both the zero flag and carry flags are 0, then it means that in the last instruction, the first has been bigger than the second one. As you see, we compare the R10 variable, the R10 variable is right. The contents in the R10 register and the content in the R9 register. And if as we saw, if R10 is bigger than R9, then the zero flag would be 0 and also the carry flag would be 0, and none of them would be set, and we saw it and we proved it in the previous lectures using the GDB. But the jump instruction for this purpose is not JP. JP actually looks at the parity flag, and depending on these two it would change. For example, in here, if I instead of 5 and 2 say 6 and 2, the parity flag in here wouldn't be set, because the number of ones in the 4, which is the result of the subtraction of these two, wouldn't be equal to an even number, and therefore we wouldn't jump. Let me prove it. I just press Ctrl O, hit enter and exit. Well, if it is not right, we won't be jumping in here and the exit would get executed. So if we just assemble it and link it and execute it, you see, well, nothing has been printed. If we go to the GDB, let me quit in here, hit enter and just execute it again, break at the starting point and run it. Also, I want to jump the assembly again. You see, this is the assembly and I want to start stepping through the program. So right now, if I look at the registers E flags in here and hit enter, none of them has been set. If we just step I and step I again, we are at 4000 and DC in here. So 4000 and DC, you see we have jumped out of the JP and it hasn't been executed, since the JP looks if the parity flag is set, and because it hasn't been set, therefore we have moved and the jump hasn't done anything. Actually, it has been moved from the jump, has been moved to the next instruction in here. So when we are in here, instead of changing the RIP register to 4000B0 so that it would jump in here, nothing would change and the RIP would be set to 4000 DC because it hasn't been changed. If we want to just do it again, let me just quit and do it again one by one so that you could see it. So break, start, run, step I, info registers, RIP. Right now we are at 4000 D1, which is this instruction to move the value of 2 into the R9 register. We step I again, we are at 4000 DA, which is at this one. Now if we look, the compare has been executed. If we look at the RIP register, it points to 4000 DA, which is the next instruction or the jump. Well, if the parity flag is set, the RIP would be set to 4000 B0. If the parity flag is not 1, then the RIP would point to 4000 and DC. Just the length of this instruction in here would be added to the address of the current instruction. So we are at 4000 DA, right? We know that the RIP would be added by the length of this instruction, which is 2 bytes. Therefore, the address of the RIP would be 4000 and DC. Since the JP hasn't changed the RIP, we would go to the next instruction, which is move EAX and 3C. So I just step I again and look at the RIP register. You see we are at 4000 and DC. Also, one more time, I want to look at the E flag register, and none of them have been set. So after this, we want to now look at the B. So now I think you know that what I mean when I said if we want to implement such a program, like if A is bigger than B, we couldn't do it using the JP. JP only checks the parity, not one of the variables being bigger than the other. For this purpose, we use another jump called JA. So JA, instead of parity flag, it would look at the carry flag, which is the first flag actually, and the Z flag, which is the third flag, I think, from the right. So in here, I just save it, execute, assemble it, link it, and execute it. And as you see, we have hello world printed. We don't need to even go to the debugger, but just for making sure, we go in here again, break at start, run, step I a couple of times. We are at 4000 D7. In here, the compare, let me step through this. Now, if we look at different registers, like the E flags in here and hit enter, you see none of them have been just set. We go to the Python interpreter. I just want to see the 200 and actually, sorry, I just want to see the binary representation of 202. And if you look, neither the first bit nor the third bit have been set. Therefore, the ZF or CF, both of the flags are 0. And then the jump A, in here, the JA instruction would just change the RIP register to 4000 and B0 instead of 4000 and DC, or it would overwrite the 4000 and DC to 4000 and B0 in here. So again, right now, if we look at the RIP register, we have 4000 and DA, which currently we are in here. Now look, I say step I, and now if we check it, it says 4000 and B0, which has been moved in here. And now after a couple of other step I, we would print it on the screen, since you see we are in the printing label in here. So we have hello world in here, and it would just repeat over and over again, since 6 is always bigger than 2, and therefore the C flags, the Z flags and the C flag, both of them would be always 0, and the jump A would always jump to the 4000 and B0.